Hello there once again. Today we're going to be talking about finding perimeter, circumference, and area. A lot of the formulas we're going to be talking about today are probably very familiar to you. We're going to keep the shapes kind of simple. It is a nice little brief little introduction to this kind of stuff. But it is still important to have these written down somewhere. So when you write your formulas, please make sure that you are writing this down there. Alright, so let's go ahead and get started. As always, we have a ton of definitions for you, so we always start off with some definitions here. Alright, so perimeter, something that you're probably familiar with, but this represents the distance around a figure. Typically, we go around and count how long each section is, and then we add them all up together. Then we have our circumference, so this kind of is a little bit like perimeter, but it's to deal with more circular shapes. This is the distance around a circle. And then we have area, and that is the amount of surface that is covered by a specific figure. And we're going to go through some formulas to find the perimeter, circumference, and the area of certain shapes. Now, to kind of determine the difference between this, the perimeter and the circumference is we can essentially take a shape and lay it out in a straight line and use a ruler to measure it. So these are always measured in units of length. For example, we use meters. We can abbreviate that as M, or we can do it with feet using the abbreviation of FT. Obviously, there are many, many, many more. Okay, but the whole idea here is that I can lay out the perimeter flat and lie it up against the ruler. However, area is a little bit different. Area is measured in square units, okay, because we're talking about a space between. So we use a exponent, as you can see here with the letter M. So let me go ahead and pick out a nice bright color. Let's go with green there. Let's see how that comes out. You can see that little 2 there and that little 2 there. We got square meters or square feet. Okay, so 1 square foot, now we're dealing with space in between here, while the perimeter was the length that went around this, where if I were to, say, break it off right here, I could draw that perimeter straight in a line like that, which is why I can measure it with just meters or feet. Okay, so let's go through some of the common ones that you probably have seen already, but again, this is just a nice review. The first one is a square. Okay, so this one is dealing with perimeter and our area all in one. So for a square, there's something really special about these. They have all the side lengths are the same. So if we know one of the side lengths to find the perimeter, we can do 4 times that side length or side S. Okay, now do we have to do it that way? Obviously not. These are just to make things a little bit simpler for us. Same thing with our area. Our area is the side squared. Now, the rectangle is technically all squares are also rectangles, so we can use the same formulas for that. But a rectangle, more often than not, has 2 different side lengths. Okay, the ones on this side are always going to, not always, but most often will be different than this length here. Okay, so we call it length by width there. You can probably have also heard it as base times height. You can use B and H or L and W, does not really matter. Here we're going to do L and W. So to find the perimeter, since a rectangle's opposite sides are equal, we can take 2 times the length plus 2 times the width, and that would give our perimeter. Could we just add up all the sides? Yes, we can. This is just a way to make things shorter. Now to find the area, or the space in between here, we're going to multiply length times the width. Now moving on to our triangle. We got a lot more letters going on with the triangle. Since we don't know the side lengths of our angles, we're going to call that just A, B, and C. And typically the base is found here at the bottom. Is it always? No, it's not. Sometimes this A here, this could be our base. It really just depends on where the height is. Okay, so B being the base and H being the height. To find the perimeter first, we can add up all the sides. We don't know the length. Some of them can be the same. Some of them, they might all be different. Only 2 of them could be the same. We'll talk more about triangles later. But to find the perimeter, this is a case where we are going to add up all the sides. Now to find the area. Area is equal to 1/2 base times the height. To identify where the base and the height is, you're going to search for this special symbol here, which is a right angle. The reason I'm saying that is because sometimes we can find it on the outside, sometimes it's on the inside, sometimes it can be found going in this direction. For example, a right triangle like this, our base and our height are the side lengths. But a triangle like the one we have up here, the side length does represent the base, but the height is inside. We can also find it if we have, say, an obtuse triangle with something like this. The height is on the outside, and the base is going to be found along here. However, we're only going to take that measurement there. Okay, so the area of a triangle is 1/2 times the base times the height. Then finally, we have the circle. The circle, you can use 2 different things for circumference. We first have using the diameter, so the circumference can be the pi times d, or you can cut that d in half and get the radius, and then we can use 2 pi r. The reason this is they are equal to each other is because if I did 2 times r, I get back to the diameter. So it doesn't matter which one you want to do. The special thing is twinkle, twinkle, little star, circumference equals 2 pi r. Just a nice little jingle for you to remember. Okay, the area is pi r squared. You can remember Fuzzy Wuzzy was a bear. Area equals pi r squared. It's just something fun that you might have heard in the past. Some of you might not have. Okay. All right, so let's move on here. Let's take a look at a couple of examples. What we're going to do is find the perimeter and the area of them. So this is a rectangle. You can tell because of the right angles. We've got 2 different side lengths here. So we can do 2 times the length plus 2 times the width. And we get a total of 46 feet. I'm going to go through and find the area now. It's length times width, or 14 times 9. And I get a total of 126 feet squared. Take a look at my notation. The perimeter is feet and the area is feet squared. Okay, so make sure you're using the correct notation. All right, for the second example here, we are dealing with a triangle. So for the perimeter, I'm just going to add up all the sides. So 13 plus 12 plus 5 to get a total of 30. Now for our area, we want to do base times height. You have to be able to identify what the base and the height is. Again, find that right angle. That means the 2 lines that are making up that right angle is the base and the height. Okay, so the 12 and the 5 is what we're going to be using. So it's 1/2 times 12 times 5. And we get a total of 30 inches squared. Again, inches versus inches squared. That information is very crucial. Okay, finally we're going to do the circle. Instead of perimeter now, same idea, but it's called something different, called the circumference. We're going to do 2 times pi times r. I'm going to use 3.14 in my calculation, but you can use a pi button on your calculator if you would like, and you get a more specific answer. You could also have just done 30 times 3.14. In either case, you'll get the 94.2 yards. Again, that's representing how far around the circle we are going. The area, pi r squared, sorry, I forgot that little, there we go, perfect. All right, pi r squared, so we know the radius is 15. We're looking for what is this area in the middle here. We can go ahead and plug and chug that and round that, obviously, and get 706 yards squared. Okay? All right, moving on to our next one here. A little bit different. Now, I'm giving you the area. And as you can see, based upon this right angle here, this is representing our height. My goal in this problem is to find what is the base, or in other words, what is this value of b here. So I'm going to use, sorry about that, I am going to use the area formula that I have. So specifically, it's the area is 1/2 times base times height. And I'm going to substitute in what I know. So in this case here, I'm actually told what the area is. The area was right here is 55.5. That's what's going to go in here for A. And I'm told that right here, like I said, this is our height. That's going to go in here for H. So when I substitute that in, I get 55.5 equals 1/2 times B times 9.25. Now there are a number of ways of how you can complete this problem. You can go ahead and multiply 1/2 times 9.25, since you're allowed to do that with multiplication. Or we can get rid of the fraction, which is what I love to do, is get rid of fractions. And the way that we do that is multiply by the reciprocals. So the fraction I have is 1/2. So what I'm going to do is multiply both of these sides by 2. 1/2 times 2 cancels out to give us 1, so it's gone. But 1/2 or 2 times 55.5 is 111. So we know that 111 is equal to b times 9.25. Using algebra, opposite operation, we're going to divide, and we find that the measure of the base is 12 meters. You can always go back and guess or check and do 12 times 69.25 times 1/2 and make sure you're going back to 55.5. Okay, so I can do this with I circled, I can do this with our rectangles or squares. So just be aware that if I'm giving you the area, we're substituting it in a different place. All right, moving on to our next example here. We're dealing with now a basketball court as shown to the right. We want to find the perimeter and we want to find the area of that rectangular basketball court. So this is just a real life example that doesn't mean anything's different or anything like that. So for perimeter, we're going to do 2 times the length. So we'll do 2 times 84. Plus 2 times the width, or 2 times 50. So when I multiply this out, on the left, I get 168. Down here, the next number I get is 100. So our perimeter is 268 feet. However, if I want to do the area is length times width, so I'm going to multiply 50 times that by 84, and we should get a total of 4,200. And again, this is area, so it is square footage like that. And that's all that goes on with that one. All right, on to the next one here. I'm giving you coordinates. So now we're doing everything on a coordinate plane. And we have 3 vertices. We got one at 1, 2. So let's go ahead and graph that. So we're going to go over 1 on the x-axis and up 2 on the y-axis. And I get that point right there. The next one is at 4, 6. So this guy is Q, so I'm going to label it as Q. I'm going to go over 4 and up 6. So this is our R. And then over 5 and up 2. So this here is our S. And we're going to go ahead and connect that to form a triangle. And what I want to do now is find the approximate perimeter of this triangle. So what we have to do is find the lengths of all these sides, which means we're going to be using the dreaded distance formula. So let's go ahead and do that now. So the first one I'm going to find, let's actually label it with a better one here. The first one I'm going to find here, I'm going to do one of them and I'll give you what the answers to the rest are, is let's find the length of RS here, okay? So when I find the length of RS, so remember with distance, when I label it like this, RS, that means I'm looking for a length of it. I'm going to do the square root and taking a look at the values of R and S here, I'm going to do 5 minus 4, or 1, squared, plus, I'm going to subtract the x value, so 2 minus 6, which is negative 4, but I'm just going to write that down as a positive 4 because it does not matter, so I get 4 squared. So 1 squared plus 4 squared is 1 plus 16, so I have a total of the square root of 17. And if I were to evaluate that, let's round it to 2 decimal places, I get about 4.12. Now to find QS, QS is a lot easier than that. Okay, since it's going across and it is parallel to our x-axis here, I can essentially count. So I can count over, it's going 1, 2, 3, 4. I can find that that's the length of 4. And then finally, finding the length of QR. Okay, again, I'm going to do the distance formula. Same process. It ends up with 3 squared plus 4 squared. We find that it is 5. So the perimeter, we're going to take 4.12 plus 4 plus 5, and we get a total of about 13.12. Okay, and we don't have any units, so we can use the letter U. All right, our very final example here today, we're talking about an ice resurfacing machine is used to smooth the surface of the ice at a skating rink. The machine can resurface about 50 square yards of ice in 1 minute. About how many minutes does it take the machine to resurface a rectangular skating rink? So we're going to draw that rectangle. That is 200 feet long and 90 feet wide. So what do I need first? I need my area. So I'm going to find the area of this rectangle, and I'm going to do 200. I'm going to multiply that by 90, and I get a total of 18,000. And now this represents feet squared. What I actually need is square yards, because if you take a look at the directions here, this talks about square yards. So we have to figure out something. So if I'm going to represent 1 yard squared, so this is 1 yard, and this is 1 yard. Okay, this is 1 yard squared. What is that in terms of feet? Well, 1 yard compares to 3 feet. So if this is 3 feet by 3 feet, then that means 1 yard squared is actually equal to 9 square feet. So to figure out how much this is in terms of yards, I'm going to work my way backwards, so I need to divide by 9. So I'm going to take the 18,000, sorry, and divide it by 9, and I get a total of 2,000 square yards. Okay, so now that I know that this entire area here is 2,000 square yards, what I'm going to do next is figure out, well, how long is it going to take? Okay, so what that means is I'm doing 2,000 square yards, and I'm going to do 50 per minute. I'm going to divide those two things together, and I get a total of 40 minutes. Okay, so whoever is going through and doing this resurfacing, it's going to take them about 40 minutes to finish this. Please let me know if you have any questions. We'll be very happy, or I'll be very happy to answer any of them for you. All right.